Okay, so here's the situation. Our local agency having jurisdiction has activated our team. They've asked us if we can set up our Tactical Winlink Gateway just outside of the disaster zone. We're going to be co-located fairly near where the incident command post is going to be. And they want us to be able to take in both voice traffic as well as Winlink traffic directly from the field. Now, there are likely to be a lot of operators that are going to be out there sending in their traffic from search and rescue, hams that are out, establishing communications, and so forth. They want us to be able to pull that traffic in via both VHF and HF. On the HF side, it'll mostly be a combination of near vertical incident skywave or traffic that's going to come in just directly via ground wave. Now, for the incident, the ComL has reached out to the Verizon Rapid Response Team, and they've requested a portable Starlink system. Now, we're on our way right now to go pick that system up from the Rapid Response Team at Verizon. We're going to deploy it along with our gateway, and we're going to use that as the high-speed data path from the gateway so it can send the traffic out to the commercial internet even faster. Now, we'll still have the HF side set up. It's going to be a full hybrid gateway that we're going to set up. So if for some reason there's any issues with the Starlink, the traffic can automatically be relayed out via HF. So it's a pretty good solution for right now to be able to get traffic out to our state operations center, the incident command post, as well as any other official .gov, .edu, .com, .org, whatever email address, we can deliver that traffic directly to there. So that's what we're going to set up today. Hang around and we'll show you what we're doing. Okay, so this is the Starlink. It was provided to us by the Verizon Rapid Response Team, and it's a pretty straightforward setup. This is the overall antenna, and what we're going to do is we're going to position it on the ground so that it generally has a northern view of the sky. One connection point on the bottom, it's going to connect to this crazy long cable. One end has this little connector. You can see that the connectors are not USB-C cables. There's a flat side and a wedge side. Look down inside of the port to see what the orientation is, and all of the connectors are like this. It just goes in like that. It clicks in, and that's all that needs to happen to the panel. We'll use the Pelican to kind of tilt it up a little bit so it's got a little bit more tilt towards the sky. This is the router that the long gray cable attaches to. There's a bracket that attaches onto the back. And there's two ports on the bottom. One that has an icon for an antenna, and it has the same odd shape, one side square, one side on an angle connector. It's the other side of this long gray cable. This other side here is for your network cable, and the network cable comes with the unit, and it has the same type of connector on it. The other end is a standard Ethernet connection, RJ45. And take the Starlink itself, just tilt it on a slight angle, so it's mostly pointing in a northerly direction. That's all that needs to happen to that. Now let's go ahead and wire this in to our tactical gateway. This is the satellite connection. Satellite connection goes in here, and if I look down inside, this one has the flat edge. The flat edge is right here, and it just plugs in to that, makes the connection. The AC adapter, AC cord is already here. Now this particular Starlink uses AC power. You are not able to run this one without a lot of adapters on just regular DC. And we've been monitoring it, and it does take in general about 8 to 10 amps of current to be able to run it. So we have a small little AC adapter. It's plugged into our overall power system that we have here. The power system that we're running, we have an 80 amp hour Bioenno battery that's feeding into a Buddy Pole Power Mini for the primary battery power. We've got solar connected to two 120 watt power film solar panels. Those are linked together and they flow into the solar charging port here.
So the Power Mini should keep this battery afloat as long as we've got enough power going in. Its load port is then connected to the DC in on the Buddy Pole Power Plus. And so that's acting as just a straight DC source. We've got a second 60 amp hour Bio-NO battery down here that'll act as a backup to this main system. And then we've got our power distribution, one of which is going over to our inverter. So I'll take this, before I plug it in, I'm going to go ahead and make the connection for the Ethernet as well. Now this particular Starlink is configured so it has a limited number of IP addresses that it can hand out. So in this case, we're only going to hand one IP address out to our gateway, but we could configure this where this was going into a more robust network setup where the network itself was then splitting off and handing off more IP addresses. But this is what we're going to run for today. Plug this last one in. That's ready to go. I'm going to plug into this is my cover, which we can leave that on now. So that's ready to go. Plug my network cable in to the laptop. So that's ready. And now the last thing to do is just plug this into AC. Now I do have a power meter on this, so we should be able to monitor how much power the whole unit is drawing. So let me go ahead and plug this in. We'll flip the switch to the on position. All right. Okay, so the gateway is up and running. Let me bring up my browser and see if we have an internet connection first. I'll just go to google.com. And we do have an internet connection. There's no other internet here, so this is definitely coming in off the Starlink. So let's check and see what our speed capabilities are. Speedtest.net. I'm going to go ahead and hit go. And we can allow it to tell us. And there we go. We've got 235, 200 plus megs down. And we get a download test error. So more than likely what we're seeing here with the download test error, I will run this again. With the Starlink, the connection is not perfect. It will make a connection, it will have a good solid connection, it'll happen very quickly, but then periodically that connection will drop because the coverage of the satellites is not contiguous. So you got to be ready to not think you're going to be able to have perfect connectivity all the time. It works really well. In the situation of what we've got set up here, where we're running a Tactical Winlink Gateway, that will work just fine because as traffic comes into the gateway via VHF or via HF, that traffic will be stored on the gateway if there's no internet connection, and then as soon as the internet connection is there, it'll automatically forward that traffic out over the network. So let me try again and see if we can get a full complete test for speed test.
Now, Chris, does that Starlink unit put out a Wi-Fi signal that you can share?
This one does not.
So we'd have to add a router access point.
But some of them do have that capability. This particular one does not. So this is a little bit of an older unit. It's not the latest one. There's a new one that just came out. It's the Starlink Mini. It's much smaller and doesn't need AC power to run. This one does require AC power. We called around to a lot of people to try and find a portable Starlink system. Turns out they are really difficult to come by and to be able to find. So we did get a full speed test here. We got about 131 megs down and we got about 20 megs up for the total connection, which is really pretty amazing for out in the middle of nowhere for being able to set up and run this. So I'm gonna go ahead and close my browser. And at this point, our gateway is set up, it's operational. So the overall system that we have running here, our gateway is running on an HP laptop, and it's running RMS tri-mode, it's running RMS packet in order to do 2-meter VARA FM, and it's running RMS tri-mode, which is connected to VARA HF. Now we're only operating on 3 HF frequencies, so we're fully set up there. On the radio side, on the HF side, we're using the ICOM 705 as our HF station, and we're driving that into an Elecraft KXPA 100 amplifier, so we're getting 100 watts of power out on the HF side for better communication. On the VHF side, we're going into an Alinco DR135. It's just a straight 2-meter radio. This, we're using the RA board as the connection. For the 705, we're just using the USB port on that. As far as antenna setup, you can see over here we have the Chameleon Tactical Delta Loop. Now this is going to act as our HF antenna. The amplifier has a built-in tuner, so it'll make up any differences in the HF. This will work very well for NVIS as well as Skywave. On the VHF side, we have a 12-meter spider beam that's set up, and at the top you can see we've got 2 N9TAX antennas, one that's all the way at the top, and then down below that, a second N9TAX antenna. We have a second operator. Dan is playing that role. He has his portable station set up here, and he's connected to the second N9TAX. On his station, he's able to run both voice, so he can handle the voice traffic that would be coming in via VHF, as well as a Winlink station. That's our total setup. And we've been deployed here to set up the gateway and to be able to monitor traffic. Now, as part of this overall setup, we're going to take David, and he's going to go out in his big yellow rolling go box, and he'll go out to a remote location and send in some voice traffic to us that Dan will be able to process, and he'll also send in some Winlink traffic via VHF.
Hi, this is David Goldenberg, W0DHG. I've been deployed. I'm going to check in on the local voice net, and then when I get to the location that they've sent me to, I'm going to send Winlink check-in, just let them know I'm on site, and then we're going to have some additional traffic that's going to come a little later. So drive along with me. Got about a mile to go to get to my location. In the meanwhile, I'm going to check in with the net control, let them know that I'm coming, and let them know to prepare for the Winlink traffic. NR6V, W0DHG.
W0DHG, go ahead.
This is W0DHG NR6V. I'm going to get to the assigned location in about 2 or 3 minutes. Just letting you know, checking in, letting you know that there will be some Winlink traffic to be sent at that time, so please be prepared to accept and relay that traffic.
Roger, I'll pass that on. NR6V, staying line.
W0DHG, I'm monitoring. Okay, I'm on site, I'm ready to go. I'm going to send them a message, let them know that I'm here. I'm going to check in, and then we're going to go ahead and send some Winlink traffic to let them know that we're on site, and there's going to be some more traffic coming down in a little bit. So again, my truck's always...
Go ahead with your digital traffic.
Standby 1, it's coming just momentarily. So again, in my truck, it's set up all the time for the radio. I've got the orange bag with my signal link, so I'm going to get this all set up. Get the radio set up. Got my tough book ready to go. And we'll send some traffic. Open up Winlink Express. I'm going to queue up a message to Chris and let him know I'm on site. Open up our Winlink session. I'm going to send it to the tactical gateway that's set up. Start our session.
Hearing him, and it's answering.
A lot of incoming traffic. we're not going to take all that. It is going to send the 2 outgoing messages first. And we're going to deselect all the messages.
Looks like traffic sent.
And then we'll just close it out. W0DHG, did you receive my traffic?
Came through the gateway.
Yes, we did. Gateway received it at R6B.
All right, NR6V W0DHG, I'm going to go ahead and clear and wait for additional traffic.
So it received the traffic via the cellular network, which means the traffic came into the gateway via VHF and it went out via Starlink, made the connection into the CMS, and then sent it out to a real world email address. So we were able to succeed with what we were setting out to do. So we had a great time out in the field setting up and running this entire exercise. We want to request that folks do not send us a WinLink check-in this week because there is an ongoing major incident going on the East Coast. And so what we would rather have you do is let us know in the comments on YouTube what your experience with Starlink or any other high-speed alternative communication systems is. And let's talk a little bit about what some of those alternative communication systems are. The one that we're all probably most familiar with are these internet hotspots. And so these are typically, they have their own cellular connection, they have their own SIM card in them. They're available from all of the different manufacturers, all of the different major telecoms. There's a Verizon one I've got here on the left-hand side and a FirstNet hotspot there on the right. We've shown you these before. These are sometimes requested by the COML that's on the incident. Oftentimes, operators will already have these in their own personal arsenal of equipment, and you're able to use this as a kind of a backup line. You want to make sure that if you are deployed on an incident, that you are running any additional devices through the COML and make sure that it's approved to be able to use. Now, one of the drawbacks to some of these devices in a situation like a scenario like we've set up here is that they need a cellular connection. And so oftentimes, if there is no cellular connection already there for general usage, these devices are not going to be of a whole lot of use to you. So what we're mostly thinking of is on an incident, we would be looking at some additional high-speed communications, and these all must be requested by the COML on the incident. And what I'd like to do is I'd like to bring Scott up to be able to walk through some of these different options that you will likely find on a full-blown incident. So, hey, Scott, let me bring you up here.
Hey, great. Good. Yeah, I'm here, Chris. And yeah, so what you're looking at here is a cradle point. Cradle point is kind of a step up. It's a huge step up from the devices Chris just showed a minute ago. The cradle point does require a cellular signal. It brings in the cell service, puts it through the blade antennas, and then it pushes it out through the smaller 4 antennas on the opposite end, which will set up a Wi-Fi bubble to allow people to use it. One of the big differences is when you look at that small Netgear Nighthawk or the Verizon unit, you're really maxed out at about five users. Anything above that, that thing really starts to bog way down. With a cradle point, you can see users up above 30 very easily. You can segment the network. You can set up a guest network. You can do a lot of things you can't do with a Nighthawk. And then the next device we move to is a CRD. It's also CRD is known as a compact rapid deployable. So what is this? This is basically a portable cell tower. Okay, it's very effective. So what does it do? It provides me a Wi-Fi bubble of about 500 feet. It takes about 15 minutes to set up with a single person. Has multiple power sources. And this is really kind of a nice feature, is this unit comes with a Honda generator on there with a 6-gallon pony tank, which gives you about 60 hours of onboard runtime. It's just sipping the power or the fuel. I can run this from a 12-volt source. In other words, I can leave it hooked up to my vehicle and run power out of my trailer hitch into the unit, and it will fully power this unit 100%. I can also pull, it also has a built-in 50 amp hour lithium iron phosphate battery, which will give me about roughly 8 hours of runtime on there until it will need recharging. And then the generator can recharge it as it goes through. I can also pull power from shore through AC. Now, the biggest issue with this is it wants a pure sine wave. So some of those inexpensive generators out there don't produce a pure sine wave, and this thing really needs a pure sine wave to work appropriately. So what does it do for me exactly? So this unit will give me about 2 miles of cell service. I'll create a bubble. So it's putting out 5 watts, where most normal carriers on small portable cell devices only put out 2 watts. They have a federal exemption to allow them to go up to 5 watts of power. So this particular picture that you see right now has 2 sets of antennas up on it, because I actually know this unit. It's one of ours. I am running Verizon, and I'm running AT&T FirstNet on it. So what I'm running is basically it will load bank or load balance the internet or the service, but it will also fail over. If, say, Verizon quits, it's going to go strictly AT&T FirstNet. If AT&T FirstNet quits, then I can go with Verizon. I can put a third radio on here if I want to, and another set of antennas, but it's not really required. Or you can just run it with one set of antennas on it and one radio. It's a very easy to transport function. You're probably, well, how do I get it there? Well, believe it or not, this hooks on to the receiver of your trailer hitch. It is carried on the back. The wheels never touch the ground. And so I can deliver it to the site, put it on the ground, move it where I want it. It's actually designed to fit into elevators, to go into buildings, to go to the roof. It's a very effective unit. I can actually run the power, like I said, off 12 volts. There's a port on here to allow me to leave this hooked up to my vehicle, mounted, and have it running on the back of my vehicle. It has a satellite service on it, which is hooked up to Viasat-3. So I can do backhauling. So it's receiving signal, pushing it out on cell service, or creating a Wi-Fi bubble for me. And it will communicate with me via text messages or emails to let me know that if there's something wrong with the unit. In other words, if it needs fuel or it's shutting down for whatever reason. This unit is designed to be in all types of weather. It has its own built-in heater, which is a 400 BTU heater. It also has its own air conditioner to keep this thing cool in very extreme weather. A very effective unit, very portable, weighs roughly 650 pounds, and very deployable on the back of a vehicle. And then the next unit we're going to talk about is what we were commonly referred to as a cow, or a cell on wheels. So what's the difference between the last thing I talked about, the CRD, and this one? This one gives me all the same features, but it gives me about a 20-mile bubble of cell service. And obviously I can increase the Wi-Fi coverage out there. And then there are other pieces of equipment out there. One is called a Colt, which is a cellular on light truck. You see a lot of those out and about. The different carriers have those. So just different units out there. There's also another unit out there that just recently came on the market, which is a mini CRD. It fits into 2 Pelican cases, and it has a Starlink in the lid of the case. You open it up, turn it on. The other case is the radio and all the functions. And they run about $34,000. Everybody can afford one of those. But yeah, so different alternative means for high-speed communication out in the field.
And
then the last one we have is the FirstNet blimp. I actually got to experience the FirstNet blimp last time I was deployed to Louisiana on a hurricane. I was in Raceland, Louisiana, and the field behind where we were set up at, FirstNet came out and pushed up their blimp, which is tethered to the ground. It provides a bigger cellular footprint and a Wi-Fi footprint in a disaster area. Some of the drawbacks to this is it takes about two days to get this able to deploy up into the air. It has to be monitored constantly because of any wind, any significant wind or weather changes. This has to be brought back down because, again, it is tethered and it does not have the ability to remain in the air on its own. Thank you, Chris. Back to you.
Thanks, Scott. So one of the things that, especially with this, the blimp, and I think as you're starting to see all of these different options, when you have a very large disaster area that's set up, and we need to be able to bring in all of these alternative high-speed connections, there are a lot of different components that go into them. So being able to think somebody's going to be able to just flip a switch and magically we're going to have more cell coverage around and get Wi-Fi out to everywhere is really not very accurate in the reality of what it takes to get a lot of these things up. In fact, with our overall setup that we had, we did run into a lot of challenges, even with our small, simple little demonstration that we just walked through. Not everything went smoothly as planned. So I'm going to walk through the major challenges that we ran into, and the first was live testing in the field. So the whole background behind us getting started with this episode, obviously there's Hurricane Helene efforts that are going on the East Coast, and there's a YouTuber who's out there who runs a 501c3, Ryan Hall, and he managed to pull through a lot of funding that came in through viewers and purchased about 500 Starlink systems and was able to send them into the area. And so we were like, okay, so how can we help show a way that these may be able to be used, and what's the reality of kind of what's going on with these? And so we reached out, we got a Starlink system, we brought it in and hooked it up to our gateway. The challenge was we didn't have hardly any time to test everything all together. So the night before, excuse me, the night before we did the deployment, we went ahead and I set up the Starlink system, so I was familiar with it enough to be able to use it. And I did some quick testing, and this is what that looked like.
Okay, so here I am doing a speed test, and what I just got was 188 down and 26 up. And we're just kind of idling. We generally are bouncing on our current draw somewhere around 9 to 10 amps on a pretty continuous basis. Now I've got a small little inverter that's running. And here's the Starlink. This is the main body of it. And then I just have the panel sitting on the ground. It's just kind of tilted up, generally in the northern direction. So I'll do one more speed test so we can see this. Just refresh, hit go. Yeah, go ahead and use the current location. Look at that go. And while it's doing it, you can see the current draw that we've got. It's not bad. It's not awful. We're generally drawing about 9 amps, 10 amps. It does go up and down from time to time, but on an 80 amp hour battery, especially if we back that up with solar, we should be pretty good. So we should be good enough to be able to operate with this. This is great. And that's the setup. Now we'll hook this up to the gateway in the morning when we get out to the site.
So when I did the setup, this was actually the second time that I set it up. As soon as I got the unit home, I set it up and I took it out. I took the antenna base for it and set it up in my backyard. Now, my backyard, I do not have a clear view of the northern sky where you have to point this antenna at. I've got enough trees around me, and my lot has a view basically straight up into the sky. I've got a clear view above me in the sky, but not a clear view to the north. And when I first plugged the unit in when I was at home with that kind of a configuration, I did get a good connection initially, and I started the speed test and it failed. And then the connection completely dropped. And then a few minutes later, the connection would come up and it would stay stable for about a minute or two, and then it would drop again. And that was because of the satellites moving over, and I just didn't have enough view of the sky to get a clear view of the sky to maintain that connection. And you start thinking about a way that a portable Starlink system may be deployed in a lot of the areas, especially in an area where you've got heavily forested, maybe very mountainous region. You may not have a clear view of the sky. You may only have that vertical type of view. And in that case, it really was an ineffective tool until I took it out. I moved it into a slightly more open area. Once I got that clear view, it worked a whole lot better. So that was kind of the first piece. The other piece, and I kind of called it out in here, I was really focused on what's the average current draw that this was pulling. And it really was pulling 8, 9, 10 amps or so of power. And that little inverter that I was using was handling it quite well. But I didn't pay enough attention to that instantaneous pulls of power where it was jumping up into the 20, 22 amps, and it would periodically cycle into that. I talked to the folks that own the dish afterwards, and they are going to do some looking into it and see if maybe some of these Starlinks have a heater cycle that's built into them for snow melt, and so they're going to look and see if maybe those spikes of power were related to that function, if maybe that was turned on. But I didn't have any ability to get in and set up the system or manage any of the settings. I just had to work with what we had. So given the limited amount of testing that we were able to do prior to going out in the field, we came up with our power pace plan for us to be able to deploy with the overall setup. And given what we were seeing coming in from the news and reports coming in from Helene, where gasoline, diesel, other different sources of fossil fuel were very difficult to get a hold of, we decided to set up and try and leverage the same system that we use for our solar power gateway when we set that up and operate that out in the field. Basically, what we try to use is we've got a couple of high capacity batteries. We actually have an 80 amp hour, and then these are the two 60 amp hour batteries. They're all matched up. We run our primary battery into our solar charge controller. This is the Power Mini by Buddy Pole, and then here's the solar port. We'll show you the solar panels that we ran here in just a second. And this is acting as the initial solar charge controller, and so it's keeping this battery pretty much at float all of the time, given the capacity of solar charging that we had available to us. We then come out of the power out port, one of the circuits, and we'd go into the Power Plus. Now, this is another Buddy Pole product. And this one has a place for a DC in, and we're actually pulling our DC from the Power Mini. And then we hook our second battery in line to that. So this is acting as a universal power supply. So if our primary battery gets depleted fully, the Power Plus will automatically flip over to our backup battery and keep everything up and running. So it's downstream. And as the solar panels are coming in, because this is supplying DC power, the Power Plus also has a battery charger built in onto this charge port. So this is keeping this battery also at float. So the solar is really acting to keep our full system up and running, so we can really maximize our run time once the sun goes down, or if we're in a shaded area or so forth. Now on the Power Plus, there are 2 circuits on here. There's one here with 2 power pole outs and one over on this side with 2 power pole outs. The entire capacity of this unit is 40 amps of power that can be drawn out of it with the combined 2 circuits that are on here. Now, when I was setting this up, this is normally a unit that I have running on my gateway that I have running here at my house, and so I didn't do any reconfigure. You can use all of the on-screen controls right on the front panel of this, and you can balance how much power is going out to each different circuit independently, and you can manage it for the load that you're expecting. Keep that in mind, because I did not do that. Here's our solar panels that we deployed. Now, this is a pair of power film solar panels. These are 120 watts each, so we had 240 watts of solar. Generally, these are going to produce in full sun anywhere from 9 to about 12 amps of power. So it should be sufficient to keep our system generally kept topped up, even with the solar, even with the Starlink running as well on a regular basis. These work absolutely wonderful. We did have more solar capacity that we could have brought out. We had a bunch of 60 amp hour panels that we could wire in, but we just didn't go ahead and deploy those. That overall power system, though, we mentioned that the Starlink needs AC power. It must have AC power. And so this is the unit that I used for testing. It's a little small inverter. It's only a 300 watt inverter. I did some initial testing with it, you saw the night before, and this was handling the load quite well. And the only thing we were pulling off of this unit was just to power the Starlink. So figured, hey, we're good to go with all of this. We did have with us, we had a Honda generator. I had it left in the truck. We didn't bring it out to set up. We were trying to see if we could pull all of this off on just the solar and the battery operating, and we were able to do that. What we showed really did exactly happen. But let me go back in time just a little bit to the video that we just showed, and I'll show you the clip that I cut out in order to make that first part run a little bit more smoothly. And this is real time. This clip is just a little over 3 minutes long, and you can see the failure that we had, all of the troubleshooting that we did, and then getting the system back up and running.
So that's ready. And now the last thing to do is just plug this into AC. Now I do have a power meter on this, so we should be able to monitor how much power the whole unit is drawing. So let me go ahead and plug this in. We'll flip the switch to the on position. And it's drawing too much current. So I have to reset. I tripped everything. All right, fun. I have to reset how much power I'm drawing off the Power Mini. Let's turn that off. That reboots there. All this gear is sitting in the sun, which is...
Do you want to move a load to my battery?
We may need to do that. Yeah, let's move the HF. We have another 60 we could plug in if we need to. Let's move that over to yours. So that's the HF. How much battery do you have? Flip around, you're backwards.
It's 20 amp hour, I think.
Okay. So that should get all of that. In which case, let me switch these over. So that's pulling from there, and this is pulling from here. So within the Power Plus, you're able to distribute the power.
The 135 just dropped.
Yeah, I got to reboot it. I'm rebooting this now.
lost all power. Disconnect everything.
Radio's back up.
Okay. See if that will hold the load. Nope.
Nope.
All right, I'm gonna have to just go direct.
I have an inverter. Do you want to run the Starlink off my separate inverter?
No, I'm just gonna run it straight off of this
Okay.
60 amp hour battery.
I've got a separate 12 amp hour.
Well, we have a gas powered generator with us.
Plan C.
Yeah.
Are we all up and running?
It is booting. So this is actually a really good example. This Starlink draws an enormous amount of power. And so tying it into all of your ham radio gear may or may not work. You may need some dedicated systems set up to be able to handle the load of what the Starlink is going to run. So that was the setup and what we ran into, that the Starlink, when it was just running, when it was drawing only that 8 to 10 amps of power when it was normally operating, it was fine. It worked just fine with the overall system and the power distribution that we had. This is the overall diagram of what we had set out and what we initially built out while we were out in the field. And you can see here's the Power Mini to the Power Plus, and we had the inverter. It was connected into a second port on the Power Plus. It was just on its own dedicated circuit, and normally this is one that should be enough to be able to handle it, but we did run into problems with it. And so what we ultimately ended up doing was we moved the DR135 onto that circuit, so we were able to split the power between the two radio systems, and then we took the AC inverter and we plugged it directly into the second port on that Bio-NO battery. Now, the way that we had this all set, you can see the primary battery that was over here was still flowing through all of the power, and because the Power Plus is connected into this, we were still getting the charging that was happening off of our solar panels. So this still acted as a downstream, fully taking advantage of all of this, but what we were getting was the AC inverter was connected directly to that second port on the battery, so we weren't running into any of the limitations of any of the gear. Now, we could have taken the time to go in and recalibrate and reset the settings inside of the Power Plus to shift it around, maybe have 25 watts of 25 amps available to this circuit and only 15 amps available to this circuit, especially since we're running the 705 with the KXP A100. This draws very little power when it's just sitting there idle, and it only draws up enough power to be able to drive the amp, and we could scale down how much power we were driving it with in order to make everything balanced. So it is a bit of a balancing act when you're out in the field and you're dealing with these sorts of situations. So you really have to know your gear incredibly well, especially if you're going to try and integrate additional gear into your normal setup that you may or may not be familiar with. And that's very likely to happen on an incident. You might be asked to be able to integrate something that is not part of the norm that you're normally working with. Now, the next challenge that we ran into was equipment overheating. And from our previous experiences going out in the field for a lot of the tests that we've been doing, we have been running, especially here in Southern California, it's been summertime, it's been wickedly hot. When we've been going out and setting up, we've been having a lot of issues both with our own overheating in the field, but also our gear overheating in the sun, and it gets super hot very quickly. Most all ham radio gear is all black, and when it sits in the sun, it's just absorbing all of the solar energy, and it's just cranking up heat. And then when you put RF trying to go out of the different radios and equipment, very quickly you can get in a situation where your equipment is shutting down. Now, what we set up and we brought with us here is an easy up. A lot of our team all have these. They literally take, this is showing you in real time how long it took us to set it up. It's about 1 minute to set the entire thing up. It creates a nice amount of shade, but it didn't create enough shade. So as you watched in the first video there, you'll see we had some blue tarps that were hanging around, and those, as we were sitting there operating, we kept having to add more tarps to create more shade inside to keep our gear a little bit cooler. Now, the radio that we were operating with on the VHF side is this one. It's the DR135 Mark III. It's by Alinco. This is the radio that we use for a lot of our VHF gateways here. And what I've noticed is this unit, this got crazy hot, and it kept just shutting down. It was sitting in the sun, and so that ended up being one of the big issues. It would refuse to transmit quite often when it got so hot, and it would just shut itself off. It wasn't a power draw thing. It was clearly a thermal issue, and when you went to touch the top of it, it was really, really ridiculously hot. And so when we initially had our gateway all set up, everything was wired to this. It had the RA board plugged into the back, and everything was configured inside of the gateway to use this particular radio. But when we started having so many issues with it, we just flat out went to plan B. And plan B for us was to just grab my Kenwood D74, which had been being used initially when we first got on site as our initial radio communications for us to do simplex over. And in order to run this, though, this I had using the DigiRig. And so this ended up being one of those other issues where if you have to swap out radios and you have different interfaces that need to use those radios, then you have to reconfigure your Windows sound settings, your VARA settings, maybe something in WinLink to point to the correct type of mode that you're in. So it ended up slowing us down. Had this been a real incident, because we had this there, it was ready to go, we were able to get it switched over to this radio fairly quickly, and we would have then begin working on getting another mobile radio rigged up, ready to swap in. But because we had that 12-meter spider beam and our N9TAX was up 40-some feet in the air, this 5 watts created plenty enough coverage for us over a several-mile range to be able to extend out our communication. So it ended up working really well. It ended up being fine for us to do. The next challenge that we ran into was that we ran into RFI issues, possibly due to that big solar storm activity. Now, the morning that we went out to do this was the morning of that giant solar storm hit. There were radio blackouts all over the place. As a matter of fact, when we first showed up on site, and we don't have footage of this to be able to show you, but when we first got there on site and we were just using simplex to communicate with each other as we were all arriving into the location, our radios kept fully going and, breaking squelch, complete just noise would just flood in over the entire system. There was nothing you could do about stopping it. It would last some amount of time. We weren't sure what was going on. There are power lines that are across the street from where we were operating at. So we're thinking maybe it was that. And as the day went on, we realized that it was really more than likely the solar flare index, the solar flare that was causing us grief. The bursts were going all the way up into the S-band, so they were covering the area that we were operating in. As a matter of fact, after we got the gateway up, we got the Starlink up and running, we did our initial testings, we were all able to make connections. The first time we tried to pass the traffic, suddenly none of our systems could hear each other. They were transmitting, but they were not being picked up by the other locations. And so we were really scratching our head to try and figure out what's going on. We were probably hitting with many of these radio blackouts that were occurring, and normally that's only going to happen down in the HF band, but because of how intense this solar storm was, it was an X9 flare that really took the solar index and just made these blackouts all over the place. More than likely, that is exactly what we were running into there. The last thing is literally just the pressure of the time constraints that we had to work with all of this information. Now, we had worked with the team at Verizon to be able to get access to the Starlink. I picked it up the evening before, so I got it at maybe about 8 o'clock at night or so. I had to drive down to LA to pick it up and then bring it back up, do my testing in the evening. And we had 2 hours to be able to do this entire setup. And so we arrived on site at 9 a.m. is when we started our own little briefing. We set up the station, we got everything up and running, we did all of the testing, all the filming, and we rolled out. We were completely demobbed. The entire site was broken down by 11:22. So 2 hours and 22 minutes was the full elapsed time to set up this station, get it operational, get it on the air, get it fully tested, and so forth. So I do want to give a big thank you to the rapid response team at Verizon for allowing us to borrow this Starlink to be able to shoot this content and be able to do this demonstration for you all to be able to see. I also want to give a big shout out to Logan, KD6LLB. Logan is a local ham who's a regular on the show. He comes all the time. He's a supporter of the show, and he did come out to help us film this. He both ran some of the cameras for us, as well as he ended up being key with a couple of key pieces of gear. Part of the exercise of doing this was I gave very little information to the team other than, show up, bring your gear ready to kind of operate. I gave them kind of the high level, but we didn't really coordinate what gear each person was bringing with them and what adapters, what various different components that each person had. So Logan ended up really coming through for us with a couple of key wires. The Tactical Delta Loop was one that he had, and so he went ahead and just took care of setting that up for us and managing that whole antenna system. So it was really key. Big thanks to him. And of course, all of our WaveTalkers supporters. If you find any of this helpful, consider going on to our website, wavetalkers.com. We've got a buy us a coffee link, and it helps us fun being able to do all of these projects to get the content all created. And with that, what I'd like to do now, let me jump back into the booth. I'm going to bring myself back up to that, and I'm bring Dan and Scott up. And I'm not sure if David has been able to arrive. I know he's...
He texted that he was not going to be able to make it.
Okay. So, Dan, what other thoughts do you have on the overall setup that we did, the exercise, challenges, and so forth?
Well, first of all, I'll add my thanks to the Verizon guys. It really worked out. They were deployed to the I'm losing the name of the fire, but there was a brush fire in the Lake Piru area of Ventura County, and they'd been deployed to that. So when Chris got a hold of them, they were on the way back. So Chris was able to sort of intercept them on the way home, pick up the Starlink, and then of course he had to drive all the way down. Chris did a tremendous amount of driving to make this happen, not to mention all the other work. But yeah, we had time constraints, but that's sort of real life. In a disaster, you're always kind of pressed to try to get on the air as quickly as you can. And so the fact that Chris had to get the Starlink back, David had a work commitment, we had these time crunches, but they sort of simulated what we would have encountered in a real situation where, people that we're serving are saying, I got to get a message out. When can you get it out? The power stuff, again, that's just the stuff, especially when you're working with a new piece of equipment that you've only had a chance to glance at. That's what's going to happen. And you've just got to be flexible. And one of the ideas of this, as Chris said, was that we all bring the stuff we think we need, and hopefully between, in this case, the four of us, we have everything we need, and we did. It didn't work right the first time, but we got it, and we got it in a fairly short period of time, and we were able to do exactly what we wanted to accomplish.
Yeah, thanks a lot. And again, this was totally a demonstration. I mean, the folks that are out with Hurricane Helene recovery effort are dealing with the real life of what's going on, real life pressure. So it's in no way, shape, or form what they're going through there. This is just kind of a demonstration. Scott, you've been deployed on a lot of these on a lot of these incidents. How did this all kind of fit in with what you've been seeing in some of your own experiences?
Yeah, absolutely. And, I said this before, you were able to get that piece of equipment from Verizon because you had developed a relationship. And it goes back to where you can pick up the phone and request a piece of equipment, and they're willing to give it to you because they know who you are. They understand your capabilities, and it's developing that relationship for to make the operation successful. And I've had this experience numerous times out in the field. Having that relationship, being able to walk up to somebody and go, "Hey, how's it going? I remember you from," and everything just goes smooth as glass. So great presentation, great job. And, this is the reality. You're going to run into speed bumps, and understanding that you're going to have speed bumps makes it easier to overcome them because you've prepared for them and being able to do it. There was a quick comment in the YouTube, Chris. What was the name of that flexible solar panel?
Those are Power Film Solar. We work with those guys. They are supporters of the show. They were able to supply us with the panels. We use them on a lot of our different deployments. We use them with our solar power gateway when we set that up at the Baker to Vegas race and other different locations. They're not cheap, but they are by far the best as far as flexible. You can just throw them out on the ground. They come in a variety of different sizes. I have both the 120 watt panels, which is what we had deployed, as well as the 60 watt panels. The 60 watt are the normal ones that I carry with me all the time. Those are always ready. They'll run an HF station just fine and keep things up and running. So great products from those
for
guys.
The group to know that I probably will not be here next Sunday. My team has started to be spun up, and so I will probably be gone first of the week.
Yeah, and there's a good chance, keep an eye on your email. If you're one of our subscribers who signs up for our email list, keep an eye out. We'll let you know whether or not we're going to be able to do a show next Sunday or not. I am also traveling. I'm also on the road, so we may not be able to do that. If you found the information in the show helpful and insightful today, be sure to go onto our YouTube channel and like the video. Leave us a comment. Let us know what you thought of all of this. And keep an eye out. If you're here inside of our live Zoom, hang around. We're going to do the after party. We'll open up the mics. We'll take some questions, and we'll go from there. So until
Chris,
then,
before you
close,
if you could spotlight me.
Yeah, sure.
Steve Waterman shared an image which I think sort of wraps up why we do this and why this stuff is so important.
Sure,
and that's this image here. This is the WinLink traffic in the first 40 hours following the hurricane. And I think when they say a picture is worth 1,000 words, I'll shut up.
That's absolutely incredible to see. And with that, we'll say 7-3 to everyone. Thanks a lot for joining us. Hang around for the after party, and we'll see you on the next show. Thanks a lot.